Hi everyone, today's topic is greatest common factor. Remember that you do not need to write down everything, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward too much that you miss out on something important. Let's begin. A factor is something that we mentioned a little bit of last time. It's a number that can be divided evenly into the original number without remainders. So in the problem 3 times 4 equals 12, 3 and 4 are the factors because they are numbers that can be multiplied together to produce a number at the end. They can be divided evenly into the original number. They make up a multiplication problem. When you divide, you're not supposed to get a remainder. Every number has only a certain amount of factors. So unlike multiples, there's not an infinite amount. The number of factors are going to be limited by the two different sides, one on the other end and the number itself. So 1 being the lowest and the number itself being the highest. Those are the two boundaries. Make sure you jot this down before moving on. Okay, so when we talk about the greatest common factor, we mean the largest common factor shared by two or more numbers. So last time we talked about least common multiples, now we're talking about the greatest common factor. And it's because there is a limited amount of factors. So we can find the greatest. With multiples, we couldn't find the greatest because it goes on forever. It's going to be a huge number that we don't even know about. With factors, there's a limited amount, so we can find the greatest common factor. We have already used greatest common factors when we divide numbers. So for instance, in the problem, what is 12 divided by 3? The answer is 4 because the factors of 3 and 4 multiply together to get 12. So the smaller numbers, the factors, are the ones that multiply together to get that product at the end. Let's give you an example of GCF, or greatest common factor. In this problem, we have a problem that's asking us to find the greatest common factor between 12 and 16. So, like I said, the number of factors are limited. There's 1 on one end, and then there's the number itself on the other. So we have, for the factors of 12, there's 1 as the smallest and 12 as the largest. And I always connect those two numbers because they're a pair. 1 times 12 gets you to 12. Then we can work our way inside. 2 times 6 gets us 12 as well, and 3 times 4 gives us 12. And if there's nothing else in between, we know that we're done. There's nothing larger that can be multiplied by a whole number to get to 12. And there's nothing smaller that can be multiplied to get to 12. With 16, it's the same thing. The smallest factor is 1. The largest factor is itself. 1 times 16 is 16. Inside, we have 2 times 8 to get to 16, and 4 times itself, 4 times 4 to get to 16. So you're kind of going to make this rainbow-like model when you find the GCF. And then, like the least common multiple, you're going to have a lot that are in common, but here we're trying to find the greatest common factor. So there's only one answer. 1 is in common, 2 is in common, but 4 is the greatest common factor. So the answer is 4 for the GCF. The steps to finding the GCF is something that you might want to jot down in your notebook. So first, you're going to begin with your list with 1 and the original number, and make sure you connect them since they are a factor pair. They multiply together to get to that number. Then you're going to go down your list of numbers and jot down the factor pair. Make sure you connect the factor pairs. You're going to stop when you reach the middle of your factor rainbow, and we call it a rainbow because it creates the arches like a rainbow. So make sure you jot this down into your notebook, and then we're going to go over some examples. All right, let's take a look at this example. It's asking us to find the greatest common factor of 49 and 98. Pause the video and try it on your own first. All right, so we said that you begin with the list. Begin the list with 1 and the original number. So we're going to do that. I'm going to start with 49 first. 1 and the number 49. I'm leaving a lot of room in between so that I have room for other factors. I don't know how many there are at this point. For 98, we're going to do the same thing. 1 and itself. 1 and 98. Okay? And then I always want to connect my two factor pairs so that I know they go together. That's going to help me out later on when I work with factoring and the distributive property. So we're setting it up for a lesson in the future. Now we are going to go down the list. What comes after 1? That's 2. Well, 2 doesn't go into 49 because 49 is an odd number, so we can skip 2. 3. 3 doesn't exactly go into 49 evenly because 3 will give you an odd number at the end, which 3 doesn't go into. 3 times 6 gets you 18, but then you have a 1 left over. We don't want remainder, so 3 doesn't work as well. Now let's try 4. 4 doesn't quite go into it either. We end up with 9, and 4 times 2 gets you 8, but we have a remainder at the end, so that doesn't work. 5 doesn't work. For multiples of 5, they have to end with 5 or 0, so that doesn't work. It's 49. 6 doesn't work as well. Let's see, 6 times 8 is 48. So a lot of these end up with a remainder of 1, so very close but not quite. Let's try 7. Well, 7 does go into 49 because 7 times 7 is 49. And we end up with a remainder of 0, so it goes in evenly. Now, after 7 is 8, and once you find out that the number multiplied by itself is a factor, you've reached the middle of your rainbow, your factor rainbow, because the pair is itself. So we know we can stop, okay? If we were to use 8, 8 times 6 was the one we would have used, and that kind of repeats the 6 from before. So we know we've reached the middle and we can stop, okay? I'm going to go ahead and erase this stuff so that I have some more room. Oops. Erasing that stuff. Okay. So now let's go with 98. For 98, let's go down the list. So we have 2. Does 2 go into 98? It looks like it does because it's an even number. 2 times 4 is 8. 9 minus 8 is 1. So this is 9. 2 times 9 is 18 with the remainder of 0. Okay, so we have 2 that goes into it, and 2 is paired up with 49. So 2 and 49. Now all our numbers that remain are the ones between 2 and 49. We're just going to keep on narrowing it down. All numbers between 49 and 98 just automatically don't work because we already found these outside pairs. We're basically narrowing it down here. Okay, let's try 3 now. Does 3 go into 98? 3 times 3 is 9. And does 3 go into 8? It does not. The closest is probably 2, so that'll give us a remainder of 2. That doesn't work. Let's try 4. Does 4 work? 4 times 2 will get us to 8. Bring that down, 18. Well, 4 times 4 gives us 16. That has a remainder of 2. So 4 doesn't work either. Let's try 5. Well, 5 we don't even have to try because it has to end with a 5 or a 0. And 98 doesn't end with a 5 or a 0. Let's try 6. Does 6 go into 98? 6 times 1 is 6. That's a remainder of 3. 6 times 6 gives us 36. So that's a remainder of 2. That doesn't work. Okay, that's good. We're narrowing things down. 7. 7 goes into 9 one time. The remainder of 2. 7 goes into 28 4 times. That's good. There's a remainder of 0 there. So we want that. Ooh, I accidentally crossed out the 2. 2 did work. I just noticed that. Okay. So 7 works, and its partner in crime is 14. We want to make sure that we connect those. So now all our numbers that we can try are in between 7 and 14. We're very close to the middle, okay? Remember for 49, the middle was 7 because it was its own pair. We reached the middle there. So right now we're still trying to reach the middle. Let's see, 8. Does 8 work? 8 goes into 9 one time, the remainder of 1. Does 8 go into 18? It goes into 16, and you have a remainder of 2, so that doesn't work. Okay, let's try 9. Well, I already know that 9 can't go into 98 because 9 is going to go into 9, and then we have 8. 9 can't go into 8 and even them out, so 9 doesn't work either. 10 doesn't work because it has to be a multiple of 10. I don't think 11 works, but we can try it out. 11 can go in, let's say, 8 times. 88 with a remainder of 10. That's not good. Let's see, does 12 go into it? Now we're just going to 12 and 13. That's all we have left over. So if 12 and 13 don't work, then we're done. Let's see, 12 can multiply by, I don't know, 6? 7? Probably 7. Yeah, and then it has a, nope, I think it's maybe 8. 8. Yep, and then it has a remainder of 2. So 12 doesn't work. And then 13 definitely can't work because in order for 13 to work, it would have to be its own pair. 13 times 13 is too big. It's 169. So that doesn't work. Okay? If you know your divisibility rules well, then you won't have to do so much work. But I'm just showing you all the work that you have to go through if you don't know your rules as well. And 98 is also a bigger number, so that's why we had to do a little extra work. So all the stuff in the middle didn't work, so we already reached our middle. So now let's circle our common factors. They both have 1. They both have 7. And they both have 49. Look at that. I wouldn't have thought that the greatest common factor would be that big, but it looks like it's 49. And remember, all this work is because 98 was such a big number. Let's try one more problem. Go ahead and pause the video, see if you can solve this one. This one has 3. What's the greatest common factor between 10, 30, and 45? All right, so let's do 10, 30, and 45. So 10 has 1 and 10. Connect those. 30 has 1 and 30. Connect. And 45 has 1 and 45. All right, let's see. Let's try 2 first. We're going down the list. 2 times 5 gets you to 10. Does 3 go into 10? No. 4 go into 10? No. So that's it. We reached the middle. 30. Let's see. What multiplied by 2 will get you to 30? Well, let's see. 2 goes into 3 one time. Remainder of 1, bring down the 0. 2 goes into 10 5 times. So that's 15. 2 times 15 gets us to 30. Let's go down the list. What about 3? Well, 3 times 10 will get you to 30 because it's a multiple of 10. Connect those. And let's see, 4, no. 5, oh yeah, 5 times 6. I hope that's my middle. It's got to be my middle because 5 and 6 are right next to each other. There's no more numbers in between. So I've reached my middle. Almost there. Okay, let's go down the list. 2. 2 can't go into 45 because it's not an even number. So we got to try 3 now. Let's see, does 3 go into 45? 1 time, remainder of 1, bring down the 5. 3 goes into 15 5 times for a remainder of 0. So 3 and 15, connect those. Let's see, does 4 go into it? No. 4 times 11 is 44, that's too small. 5, oh, 5 times 9. 5 times 9 is 45. Let's see, then we just have 6, 7, and 8 in between. And let's see, 6 doesn't work, 7 doesn't work, and 8 doesn't work. So we reached our middle, okay? You can definitely always use a multiplication table to help you out with these problems so that it goes quicker. Let's circle all of our common factors. They all have 1, obviously. Everyone's going to have 1. Not everybody has 2 or 3. Okay, they all have 5. Let's see, not everybody has 10, and that's pretty much it. Okay, so it looks like our common factor is 5. Okay, so practice this at home. This is going to be utilizing a lot of your multiplication skills. So again, use your multiplication table if you need that extra leg up. Let me know if you have any questions, and just make sure you don't give up on listing the factors because sometimes people get lazy and then the one pair that they skip is the one that has the answer in it. Okay? So let me know if you have questions, and if not, I'll see you in class.